Okay, guys, so we'll get started now. Actually, let me just see who I've got here. All right, Matar, is it? That's you, okay. Umar, yeah. Diana, yeah. Priscilla, Hussein, okay. Abdulaziz, Daria, here. Nikita, here. Okay. Ratimi, is it? Yeah. Alex, okay. Patrick, Mohammed K, and Mo. Okay. David, Hazza, Sabrina, there you are. Vanessa, Ishpreet, Jawar, or Jafar, Jawar, who's that? Oh, he's not here. Andy has a difficult name. Okay. Amy, Joshua, Ray, Barak, and that's everybody, right? Did I miss anybody? No? I got everybody? No, you don't exist, I'm afraid. Sorry. You only think you're here. You're science, right? You're science?
No.
Health science? Business. Ah, well, you're definitely in the wrong room, so. Yeah. That explains that. You're down in Cav. You know this room? Yeah. Anybody else? No? And do we know why he's not here? Oh, she, okay. Oh, she'll be back then. All right.
No, she's absent.
So I actually have everybody, more or less. Extra, too. All right, let's get started. So, okay, so we're going to begin by looking at the equation of the line. No. Hey. No, I want you using English. Yes, and have you got your notebook out? No. Making notes. Paper time. Y'all got paper, right?
Yeah.
Yeah, well, come on.
Can I use it's a tablet.
Oh, but yeah, that's fine, yeah. You have a writing pen, is it? Good, okay, yeah. Now look, this first topic, I know it's going to be familiar to a lot of you, maybe even all of you, but still, there's no harm on brushing up on things, and in fact, maybe some of the vocabulary is new. So if we start off with how to represent points. Now I know you all seen this before, but let's just check our English here. So what is the name of this type of graph? Are you staying or going?
Yeah, I just want to sit in the front.
Oh yeah, that's fine, that's fine.
Be closer to you.
Yes, good idea. You're back. Yeah. I thought we decided which room you're in. What did you forget?
Telephone.
Did you lose your phone?
Right.
There's no. Okay, so as I was saying, what's the name of this graph? Yeah, Cartesian, or we can also just call it XY, but you're right, Cartesian, yeah. And just also, while we're checking vocabulary here, the name of these guys, this one and this one?
Axis Y.
X what?
Axis.
Axis, yeah. Y-axis, yeah. Okay, good, 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 good. And the name of the guy in the middle here? Center? Nah. Origin, yeah. Okay, and then this here, if it was something like XY coordinate, or we can also call it, what's simpler? Not in between the two. Not as simple as dot, but not as hard as coordinate. Point, yeah. So you can call it a coordinate, or if you just want to keep it simple, you can call it a point. Yeah, that's kind of the basic vocabulary. And you're all familiar with how these work. So what is the verbs we can use? If I want you to, let's say 2, 3 on a XY graph. What's the verbs I can have here? What verb could I use?
Plot.
Plot, good, yeah. There's actually a few. I want to make sure you know them all. So, as a verb, it is a verb, but we can't use it here. What else could we have?
Draw.
Yeah, draw's okay, yeah. What else? No, not this one. Nice try though, not this. It's okay, it's okay. I wouldn't use it, but it's okay. What else? Represent, yeah. Show. Indicate, okay, we're getting the idea now. Show, represent, indicate, illustrate.
Represent.
Yeah. Just, so you know, in the exam, plot, when they use this word, it means that they want you to draw it very carefully. Okay, all the other words like draw or show or sketch or represent, you can be a little bit rough with it. But as soon as they use the word plot, that means you have to be, careful with how you draw it. Okay, so it's worth making note of that. That plot means you have to be accurate. Be very careful with it. Okay, but if I just said something like draw, then we don't have to be so accurate about it. Okay. Right, so this one here, we know how this guy goes. XY, 2 units to the right, and then 3 units up. And there it is there. And we also know that this side here is negative.
And there as well.
And then down here as well is negative as well. Okay. Quick question. So we have scale here, don't we? Like this represents 1 unit and this represents 1 unit.
Yeah.
So what I want to know, could we have something like this where maybe we go, that's 1 unit, that's 1 unit, and then here we could go something like that's maybe 2 units and that's 4 units. So can we keep, or must we keep the scale the same, or can we change it?
As long as
we
the
can
x-axis follows a similar pattern and the y-axis.
So you're saying as long as the x is the same, the y is the same, but they don't both have to be the same as each other. So let's see, what do we think? Is that we agree or disagree?
Yeah,
so
we
can these be the same, or can they be different? I guess is what I'm saying. Yes or no?
Yes, they can.
Yeah, they can be different, but you have the right idea. We just need to keep it the same within each of them. But we're allowed to make the scale different to each other. So we could even go 20, 40, that's fine. What we can't do is this, 1, 2, 10. Yeah? And you're thinking, of course not. But yet, I see this in the exam sometimes. So I'm saying it because I have seen it before. Right, so okay, so now we have some basic vocabulary down. Yeah? Question? No? So now that we have some basic vocabulary down, let's actually look at some formulas. So the first one I want to have a look at, first thing to look at is the midpoint. This is a word some people have heard before, I'm sure. Yeah. What's another way of describing midpoint? What's the meaning of midpoint? Like halfway, or middle, or average even.
Yeah.
So let's see who remembers their formula from high school. The midpoint between
a plus b divided by 2.
Well, let's put in letters x1, y1. Okay. So x1, y1 and x2, y2.
Yeah, we add xy and x2.
x1, x2 over 2, yeah. And then the same for the y. And this gives us a point that is in the middle of 2. Yeah. Basic stuff that maybe you remember, maybe not, but there you go. So it gives us the middle point. I like to think of it as an average point. The reason I like to think of it as an average point is because it also works if you have 3 points.
Yeah.
If I gave you 3 points, you could say x1 plus x2 plus x3 over 3, and y1 plus y2 plus y3 over 3. And it also gives you a point in the middle. So it's like an average point here. So let's just do a simple little example. So this is our first example. You might get this in the exam, but if you get it in the exam, it'll be for 1 mark. Okay, so it's really straightforward. So the question would be something like, find the midpoint of, I'll make up some numbers, 6, 7, and let's say, I don't know, 4, 3. Okay, so this should only take us a few seconds to do. Yeah, 6 plus 4 over 2, and 7 plus 3 over 2, and that gives us 5, 5. So that's our first example done. So I'll just give you a minute to be writing this down. Even though you've done it before, it is good just to write it down, because then you know what topics you're having on the exam. So you can just make some notes. You don't have to write every single thing down, but just get the main things down at least. Okay, can I scroll down? Yeah. Okay, so next thing we want to have a look at is the equation of the line. So there's 2 ways to write the equation of the line. The first way I prefer is in this form: y equals mx plus c. For those students who have an American background, you might be more familiar to mx plus b.
Oh, yeah.
Yes.
It doesn't
Or
matter.
even it doesn't matter, ax plus b.
Or like K.
Whatever, it doesn't matter. But just so you know, what I prefer is writing it like this. Okay. The reason I prefer using this form is because the m and the c both have a meaning. They both represent something about the line. So, yeah, what does the m represent? Slope, yeah. And what's another word for slope? Gradient. And what does the c represent? Y-intercept. So what does that mean exactly for the graph? Well, the c is the easy one. What's the meaning of the c? Well, we have it in the name. The y-intercept. This is where it will cross the y-axis. So, for example, if I had y equals 2x plus c, plus, let's say, 3, then this point here is on the line, the point 3 here. Okay? The m equals 2 is the slope, and that tells us how steep the graph is. So, a big number here means the graph is quite steep. A small number means it's quite shallow. A negative number means pointing downwards. Okay? So this one here, the slope is 2. So what that means is, if you go to the right 1 unit, then you need to go up 2 units. That's what the slope of 2 means. So the line needs to look like this. This is a slope of 2. If it was minus 2, it means you come out 1 unit and you go down 2 and the line is pointing downwards. Okay. So just some quick examples here. You know, if the m is quite big, the line could be like this. This is m large. If m is quite small, like 0.1, that's there. The m is quite small. Okay. And then if it's going down like this, That would be negative then. But what about if we have, I'll just squish it in here. If our line is lying horizontally, m is 0. And what about if the line is lying vertically? Infinity, kind of. It's more accurate to say it's undefined. Or you could even write it as plus or minus infinity, like this. Yeah. These are like the two extremes, the horizontal and the vertical down. Now, sometimes our equation isn't written in this form. Sometimes, oops, no, cancel. Sometimes it's written in this form. Yeah. Now, this is also fine, but I don't quite like this form as much because it's not as easy to see what the m is if it's written like this. Yeah. But it's not a big deal to rewrite this back in the previous form. So, as an example, our next example, example 2, you might get a question where you need to express, let's say, 2x plus 3y plus 10 equals 0 in the form, y equals mx plus c. And by the way, how do we describe in maths what we're doing in here? What do we call this process? I'll give you, it's where we say make y the subject. That's what we describe what we're doing here. We're putting y by itself on one side. Okay? Right, so this example isn't that big of a deal. What should I move first, do you think?
10.
I could move the 10, okay. 2x plus 3y equals minus 10. And next? Yeah, what should we do? We should move that to the right as well. And it will become minus 2x. Yeah? And finally, divide by 3. So the slope of this line is negative. And it's kind of a small negative number. If I was to very, very roughly draw this, where's the y-intercept? Minus 10 over 3. So that's about 1, 2, 3. It'd be like maybe about here. And are we going up or down? We're going down a bit, aren't we? Slightly down. So it'll be something like this. Roughly. Just a rough sketch. Okay.
Yeah.
Right, if you can write that example down. Now, usually in the exam, they won't ask you to do something like this, but what often happens is you need to do this in order to do something else. So perhaps later you actually need to know what the m is. So this is only ever going to be a first step in an exam question. Okay. Right. Next one now. So, what is this now? This is the third thing, isn't it? The third thing here. I want to, or how can we check if a point is on the line? So for this situation, you're given a line, you're given a point, and you want to know, is the point on the line or is it off the line? Now obviously you could draw it, but it's not the easiest way to do it. So for example, find which? Oh, find the zeros. No, not necessary here. We'll have to do that later for if we want to draw it. But there is a way to do it without drawing it. So, like if I said is, I don't know, 2, 2 on y equals 3x plus 4. How can we check if this point is on this line? Yeah, put it in. But how does that tell us if it's on the line or not?
If it's equal,
if it's equal, it is. If it's not equal, it's not. So let's see what happens. 2 equals 3 times 2, which is 6 plus 4. So we can say it's not on the line. 2, 2 is not on y equals 3x plus 4 then. Okay, so if you can write that example down, we'll have a look at something else now. Actually, what we'll look at next is how to draw the lines a little bit more accurately.
Use a ruler.
Step 1, use a ruler, yeah. And again, you'll be surprised how many people come to the exam without a ruler. So, okay, can I scroll down, or you need a minute?
Yeah.
Yeah.
Yes? Scroll down?
Mm-hmm.
I still see some people writing.
Yeah.
Yeah, that's okay. I'm not going to go anywhere. Right, the next thing we'll have a look at is how to graph. And you said earlier about the zeros. Yeah, what exactly are the zeros?
So it's like when you have an equation and you need to find firstly like zeros, after you need to find...
Yeah, but what exactly are the zeros? What is that? Like, explain to me what the zeros
it's like
are.
when the line is crossed aces.
That's it, yeah, where it crosses the x and the y.
Yep.
That's very useful. If you want to make a graph of a line, you need to know at least 2 points. Once you have 2 points, you can just connect them. And usually, in the exam, the points that they like you to find is where it crosses the x and the y axis. So, let's have a look at an example. Let's say, we might want, as an example, so this is how to sketch lines. Draw, no, we'll be more accurate. We'll say plot 3x, I don't know, plus 4y. Yeah, okay, equals 10. So, in order to draw this line, we need at least 2 points on the line. Normally what's good to do in the exam is find where it crosses the x and where it crosses the y, and then you can just connect them up with your ruler and you're finished. Okay. Just before I do that, we know the name of this guy, called the Y-Intercept. This guy here has a couple of different names. You already mentioned one of them. You can call it a zero. But there's another name for it. We could also call it the X-intercept. And there's one more name for it which is quite common here. Root. Yeah, we can call it the root. Which is usually what I call it here. It's normal. So, yeah, root, yeah. So we can call this point here the root. Okay. So, but I think a lot of you knew these words. Well, you know X-intercept obviously, because I just told you Y-intercept. Zero makes sense, and root is maybe the one you might not all know. Okay, let's have a look at this. So let's start by finding, we want to find this one here, the Y-intercept. Make x equal 0, yeah. So we say, let x equal 0. Let's see what y we get. So that would be 0 plus 4y equals 10. Yeah. So y equals 5 over 2 when you simplify it. Yeah, 10 over 4. Good. So we already know that point. It's 5 over 2. And I think you can see what's going to happen next. Yeah. What's the next thing?
Just put
y equals 0.
Yeah,
so you get 3x plus 0 equals 10. Yeah. 10 over 3. Okay, let's try and draw this a little neat. Yeah, plot. So I can do it neat enough here. Whoops. No, I can't. All right. There's my x-axis. There's my y-axis. Now, what's the biggest number here? 10 over 3. That's about 3.3.
Yeah, it's bigger.
So I think if we go to 4, it would be okay.
Yeah.
1. Well, I mean, you want to look at nice enough. 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4, 5. That's a 5. Minus 1, 2, 3, 4, 5. Minus 1, 2, 3, 4, 5. The y is 5 over 2. That's 2.5. That should be about there. The x is 10 over 3. It's about 3.3. So that's about there. And there you go. That's our line. Okay. This is an exam question. It's not going to be for a lot of marks. It might be for 3 marks or something. But still, it's an exam question. Okay. So once you have that example, we can look at the next thing now. You got that?
Yeah, yeah.
Yeah. Okay, let's scroll down now. So, let's see, the next thing is how we can find the equation of the line. So, in this particular example, we were given the line and we made the graph. Now let's look backwards. We're given the graph and we want to find the line. So it's literally the opposite direction. So before I do that, what is this? It's probably like the fourth thing or something, the fourth formula, the fourth point. I gave you at the start the formula for the midpoint. Now we're going to have a look at the formula for the slope. M formula. And this is for getting the slope between 2 points. Another thing that you might remember from school. I want to know what is the M here.
Y.
Yeah, what is it?
Y1.
Y2 minus Y1. Yeah. And in fact, each of these parts have a name. Y2 minus Y1 is given a name. What is it, yeah? I think I heard someone say it. Y2 minus Y1, what's that? Change?
Rise,
You could, yeah, what is it?
rise over slope.
Oh, no, you got it half right. The top is called rise. Y2 minus Y1 is called the rise. Because Y2 minus Y1 represents this distance. And X2 minus X1?
Run.
It's called the run, yeah. Which represents this distance here. Or if you want to keep the language simpler, you can just say change in Y over change in X. Yeah. But just as a single word, the top is called the rise, and this piece here is called the run. Okay? Maybe some of you have heard those two words before, perhaps? Yeah? Yeah. But we don't really have a formula for C. Anyways, let's have a look at an example. You don't always need this formula. It depends on the situation. So I'll do two examples. One example where you don't need this formula, the easy one, and then the next example is where you must use this formula. So here's an example of where maybe you don't need the formula. If I draw something like this. And we call this point here 2, and maybe this point here, oh no, I want to, sorry, that's a little bit too close. I'll just put it here. This point here could be, we could just say it's 4. I know it's not great. And this one here, we could say it's 1. Now, actually, you don't need any special formulas. If you look at this carefully enough, you can figure out what the formula is, because we already know, well, what does this tell me? That tells me the C. Doesn't it? Yeah. So what's the C here? 2. So the only thing that I don't know is the M, the slope. But if you look carefully at the graph, I kind of gave you the points.
We could put
4
4
would be
equals 1.
minus 2.
Yeah, but you don't need the formula. You could look at what's happening, yeah. If I move across here 1 unit, how much have I moved up here? 2 units. So what's the slope? 2. So you see, this is a simple example where if you look at the graph, you could figure out the line. Now, obviously, it's not going to be like as easy as that always, okay? So a more realistic example now is I give you the graph, I give you 2 points, just 2 random points on it, and we want the line. Okay, so let's go on to a more realistic example. Can I scroll down? Mm-hmm. Yeah. So let's just say, okay, here's my line, x, y, and let's just say 1 point here, I don't know, we'll just say it's 2, 5, and then this one here could be like 4, 10. And I want the equation of this line. And this is much more typical of what you might get in the exam. Okay? Do you want to give it a go?
Oh, no.
Well, let's have a look at it. What should I do first? I should get the gradient first, the slope. And that's not too bad here. M equals, so 10 minus 5. Yeah, so that's 5 over 2. 2.5. We prefer to leave it as 5 over 2. So you realize we're halfway finished. All that's left to do now is to get the C. Now, there's two ways to go forward, and I'll show you both ways because it depends on what you prefer. So the first way is just to use this formula, and the second way is to use this formula. I don't mind, I'll show you both ways. So if I want to use this formula, first I put in my m, which I know. It's 5 over 2x plus c. And then to finish, how do I get the c? Use one of the points, yeah. Which point?
2 and 5.
Yeah, why? Smaller numbers means less brain power, yeah. So we'll use this one here, although you could use either. So if I use 2, 5, I get 5 equals 5 over 2 times 2, which is nice, plus c. So what's c here? C works out to be 0. Because you get 5 equals 5 plus c. So we have our answer. Y equals 5 over 2x plus 0. So actually I'll just leave it as 5 over 2x. Now for those students who have seen this formula before, that's fine. You just sub in all the info. So y is y. y1 is either, whichever one. So again, let's use this one. So y minus 5 equals, and what's the m? It's still 5 over 2. X minus, and in this case, x1 is 2. Yeah? The only problem with this is we have to clean it up. So let's clean it up. Y minus 5 equals 5 over 2x minus 5 over 2 times minus 2 is 5. Taking this to the other side, again, they cancel. So you're left with the same thing. It doesn't matter. In the exam, they don't care. Whichever you would like to use is fine. I'm showing you this because some people have seen this and some people have seen this. Whichever, it doesn't matter. But I think in the exam, this one here is usually preferred, but I mean it's the same amount of marks. What I mean by preferred is sometimes the way the question is made, it's sometimes a little easier to do it this way, but it doesn't really matter too much. Okay, right. Last thing to have a look at is some special types of lines. So there's we don't have to go through this trouble if the line is quite a special type, like a horizontal or a vertical line. In fact, in situations where you have horizontal and vertical lines, that's like a special case. You can jump to the answer straight away. So if I just scroll down a bit.
Yep.
Yeah. So suppose I have xy, and I want the equation of this line, which lies horizontal, and I'll give you 1 point on it. Let's just say it's 4, 5. Right, so what's the equation of this line? The horizontal line that passes through the point 4, 5. Y equals 5. Good. And the reason for that is, everywhere on this line, the y is always 5. You're always 5 units above the axis. So this line can just be represented quite simply as the line y equals 5. And that's the equation of the line. Nothing else. You could probably guess what's going to happen next. If I draw another line xy, and let's make it a vertical line, and let's put it through the point, I don't know, 2, 3. X equals 2. That's the equation of this line. X equals 2 and y equals 5. So look, what I'm saying is usually the equation of the line, you can write it like this, but it can become much smaller if you have a special situation like a horizontal and a vertical line. In fact, in this situation here, it's impossible to write it like this. You know, what's the m here? Yeah, undefined. So you can't even write it like this. Now you could for this case. What's the m here?
0.
So if you really wanted to, you could say y equals 0x plus 5. If you really, really wanted to, but, you know, don't bother. Just leave it like y equals 5. Okay? Okay. So, we have 10 minutes left. What I usually do is just give you time to get started on your homework. Okay? So, you have the weekend. Our next class is Monday. So for the next 10 minutes, I just want you to get started on these questions. I want you to have a go at all the questions on page 4 there. Yeah? The more you do now, the less you do at the weekend. Yes?
Students, if they start, they will continue anyway.
What's that?
If we are starting
Yeah, if you
now,
start now,
yeah,
in fact, if you get them all done in 10 minutes, you have no homework.
Yeah.
That would be quite the target to try and achieve.
So
So
just-
get started, the whole page, page 4.
How are we supposed to do like the first one?
what?
It's like,
Yeah, for the first question, you could just draw one graph and put all the points on it, okay?
The song have a ruler?
Oh, it's okay for the first one. You can just be rough with it. I don't mind.
Okay,
It's okay.
don't you have a line?
It's a ruler.